Problem 2, uh, we submerge 3 connected tubes into 3 container filled with fluid 0.8, 1.3, and 1.1 gram per centimeter cube. So as you see here, the configuration, we have the 3 tubes are connected together, and each one is submerged in a certain fluid with a certain quantity of density, okay, mass per volume. And inside the tube here, we have a pump system. We are pumping air inside the tube, and we have a constant value of pressure of air inside the tube. So we have a pressure P here equals to P equals to P. We can say here we have PA, okay, PA and PA, these values are equal, okay. So we have equals value of PA applied from the internal side of the system, and here externally we have P0 applied by the atmospheric pressure P0, the same P0 and P0, okay. As we have a different density of fluids, so we get a different height. As you see here, we have different heights of fluid 1, 2, and 3. I give you this height, which is equal H2. We can say here fluid 1, 2, 3, and here we have H1, H2, and H3. Okay, this is a given. Now I ask you to find H1 and H3. Simply, we have H2, where H2 equals to 11 centimeter. We have a static state situation. It means we have a hydrostatic fluid. I don't have any dynamic, okay? We don't have a flow of fluid. We have a static fluid. It means we have a constant velocity equals to 0. So first of all, we can take the second fluid. As we have the height, we can apply, P below equals to P above plus rho GH. Okay, here we have point A. We can say here we have point, okay, we can start by this one. Here we have A and B. PA equals to PB. As we have same fluid, same level, we get same pressure. Okay, so we have same level and same liquid. So and PA equals to P0. So we can say PA equals to PB equals to P0 equals to 10.5 Pascal. In general, if I don't ask you to calculate, you can use directly P0 equals to 10 power 5 Pascal. Okay, and between B and PA, okay, let's say we have here B prime, okay, P B prime equals to PA, okay, equals to PA. So between B and B prime. We can say P below PB equals to P above P B prime plus rho 2 G H2. Okay, we have PB equals to P0 and PB prime equals to PA. In general, we have H2, we have G rho 2 PB. We can calculate PB prime from the second fluid. So PB prime or PA, okay, here we have P0 equals to PA plus rho 2 G H2. We can find PA, which is equal to PO minus rho 2. You know, here I give you in gram per centimeter cube. You have to convert the unit to kilogram per centimeter cube. You know, 1.1 gram per centimeter cube equals to 1.1 times 10 power 3 kilogram per meter cube. Okay, so we can calculate PA, which is equal to P0 minus rho 2 1.1 times 10 power 3 times G. We can take G by approximation equals to 10 times H equals to 11 in meter. We have okay, we can take 11 times 10 power minus 2. This is the value of PA. We can calculate PA. You know, PA is a pressure applied by the pump system. Okay. We get about 98,790 Pascal. This is PA. Now we can use this PA for the first one and for the third one to calculate H1 and H3. Okay, so now I take case one, this one. In the case one, we can take, as you see, between this point and this point, we can say here we have point C and D, and here we have PA, where we have a point D prime. So between D and D prime, first of all, we have PC equals to PD equals to PO, which is equal to 10. We can say equals to PO equals to 10.5 Pascal. Okay. Here we have P C. Okay, now we can take D and D prime. We can say P D equals to P D prime. You know, here we can say P D prime equals to PA. Okay, we have PA inside. We have PA. Okay, we calculated already. PD equals to PD prime plus rho 1 G H1. So we have PD, which is equal to P0 equals to PD prime equals to PA plus rho 1 equals to 0.8 times 10 power 3 kilogram per meter cube. G times H1. I need to calculate H1. We can say here H1 equals to PO 10 5 Pascal minus PA 98 790 Pascal divided by 0.8 times 10 power 3 times 10. We get H1. We get 0.15 meter, or we can have 15 centimeter. Okay, so here we have 15 centimeter, here we have 11 centimeter, and you can follow the same calculation to calculate H3. It will be smaller than H1 and H2. Okay, I will not solve it. You can do it alone.